Okay. So we left off with this here. Okay. We just have a little bit of content to go over to stay on schedule. I see crayfish, which is part of the aquatic arthropods. Okay. The quicker we get rolling on this, the quicker we're done. It's just that simple. All right. So we have some drawings that are due tomorrow. Here are your identifications over on that side. And don't forget, we went over some of those classifications of arthropods. Those were in boxes and the classes, the characteristics, and then the animal. Okay. Unless this is wrong, this is where we left off with. Is that correct? Okay. Okay. I was wondering why I had an extra copy here. Would you like it stapled? Okay. Yep, you're welcome. So notice that at that bottom term, you see it says compound eyes. Not all arthropods have compound eyes. I was under the presumption that some spiders did because some of them are jumping spiders. Okay? So with that, it would be an advantage to be able to see where it is that you are going to land, especially if you are a jumping spider. You're probably high up in the trees, and falling down obviously would not be very conducive for their survival. But most spiders have simple eyes, but in this case, some do have compound eyes. And that's more so the dragonflies and insects and some aquatic arthropods as well. Because you also have to take into consideration all the animals up to this point probably do not see at all. Sponges don't. Cnidarians don't. The mollusks, some of them do. That is true. Worms don't. Okay? So eyesight was certainly an early evolutionary advantage for this phylum of animals. So that being said, other types of adaptations, especially chemical signals in insects is one, and they communicate by what we call pheromones. Okay? And those are just chemical signals that get sent. Okay? Gentlemen, I can't talk over you. I just choose not to. All right?
I can hear you.
Okay? Okay. Does everyone have this content that wants it? Okay. So I want to get through this, okay, and then this, and then we'll get to the crustaceans. That's where we want to get to. Okay. So when we think of circulation, there's two types in the animal kingdom, you would guess. If we see an open type, well then there's going to be animals that have a closed circulatory system. And that's what the vertebrates have, is a closed type of circulation because it is pressurized. With these types of animals, it is not pressurized because since it's open, there's what we call blood sinuses instead of capillaries. and in this case here, okay? We usually just attribute this to maybe reptiles, okay? Because when we think of a specific type of reptile, what might shed its outer skin that you may have you may have even seen one of these before. It's an animal that would shed its outer skin. Yeah, snakes do that. And in order to do that, that's what allows them to grow. But it's not unique to all vertebrates because some arthropods do that as well. Pause for just a moment. Now, in this case, the reason that this is occurring, what are we talking about with an exoskeleton? Where is that protective structure located? Inside the body or outside? Yeah, it's on the outside. So that's why this animal needs to shed its outer skin, unlike the vertebrates, which grow with their skeletal system. Okay? So yes, there are some advantages to having an exoskeleton, but nature or the man upstairs designed us to have an endoskeleton, so it grows with us then. Okay, so we'll get through this, and then, like I said, I want to get through parts of this crustaceans, and then we'll be done for today. Oh. Okay. So when we look at this, as far as feeding is concerned, okay, who would have pincher-like structures? Okay, lobsters, crabs, and what's on today's schedule? Crayfish, crawfish, whichever way you want to pronounce that. But in other arthropods, okay, what might be used for food gathering? It's not the legs in spiders. What did we say yesterday or the day before? All spiders are this. I thought I heard it. All spiders are this. But they're not all dangerous. All spiders are venomous, but not all of them are dangerous. So if that's the case, what might be this chelicerae be in spiders? Which one of these structures? Be the fangs, because that is the delivery system for venom. The chelicerae or fangs is how these animals deliver their venom then. And it's different in their close cousins, the scorpions. Why would that be? They're also venomous, but their delivery system, they only have one. It's on their tail instead of on the anterior region or part of the cephalothorax. Okay. Does everyone have this content that wants it? Doesn't look like there's a lot to write. Okay. All right. Anterior region. Okay. So just want to get through this anterior region of aquatic arthropods, or not necessarily crayfish, but an aquatic arthropod nonetheless. Now, this would be true for the majority of crustaceans. Not all aquatic arthropods, but certainly the majority of crustaceans. Okay? Who has a boat in here? Okay? So you go to Lake Thompson, it doesn't matter, Lake Herman, Lake Madison. You put your boat in the water, okay? Then you'll probably see at least 3 signs that you need to do before you take your boat out of that park. Does anybody know? Someone said something about a plug. Who? Pull the plug. Yeah, pull the plug out of there so you drain the water. Does anyone know what specific arthropod you can transfer from one lake to another? And it's an invasive species, which means it multiplies in something you do not want in the lake. Zebra mussels. That's right. So the idea behind that is that when you drain that, would be my presumption, that you're limiting the amount or chance of that to go from one lake to the next. And sometimes people even wash their boats off, which I think would be a good idea to do that as well. Okay. Does everyone have this content that wants it? Okay. So you had requested this, and we had this on last hour as well. So as far as our purposes, this is all we have. We will finish talking about some of the aquatic arthropods and perhaps get to the spiders tomorrow. We'll catch up to you next time.